Okay, welcome to this next part of your entry-level PLC programming. This is the reason why I had you guys get the Logix Pro because we're going to start using it on these meetings. We'll have another meeting next month as well, beginning of the month, just like we did here. And then I'm going to have follow-up, probably a second level if any of you guys are interested to go into beyond the counters and timers just to do some math, basic subroutines, things like that, if you're interested. So what I want to do is go ahead and kind of catch you guys up. So if you guys will open up your Logix Pro, um, takes a second to pop up like mine. If you downloaded the download version, there is and I will tell you, they have a disk that you can buy. That one's kind of forever disk. And what you do is it's like running a video game, the old video games where you had to put the disk in the drive and run it. So you need a drive for that in order to use it, but you can move it from computer to computer to computer. That's what I have at work. Instead of me buying 5 of them, I just move the disk around to the different workstations and work off there if I need to have another workstation. That's the only thing that is important to you about a disk if you're going to get a disk. That way you don't have to purchase, multiple copies of it. So every time you go to a new computer, you would download it, and then the disk has the license on it. So that's kind of how that works.
Okay. Now I see my RS Logix.
Well, it should be the balloons. I don't know if you see at the bottom down here, I've got the balloons there. You should have that on your desktop somewhere. I put mine on my taskbar so I can easily get it. But the other thing, if you go into your apps, you should see it in your apps too as Logic. It might be under the Learning Pit, or it might be under Logix Pro. So it's going to be the learningpit.com, I think. Get down here to the T's. All right. What I want to do is just kind of go over some basic stuff. So what I want to do is, if you go up here to the top where it says File, Edit, Simulation on the tabs up there, and just go to IO Simulator. I want to get back and just make sure we're comfortable with where we are. Now we got through some of that. So if you go into the Logix Pro and you come up here to File, Edit, Simulate, and then when you click Simulation, just click on the IO Simulator. And you should see what I see here. The little simulation switches and lights and all that fun stuff.
And 4.
Yeah.
All right. Now what I want to do is just put in a simple bit, and then we're going to cut a light on, just a reminder. This here is your examine if closed. And what I want to talk about is examine if open, examine if closed. What it's looking for is the switch to be closed. So in other words, if I look at this little icon, this is its current state without it being on. Okay, so in other words, if you look at it as a normally open contact, which it's not, don't ever call it that because people will jump all over you. But really, that's the normal state is open, but I'm waiting for it to close. So they call examine if closed. In the 5000, it's a little better because they talk about examine if on instead of open close, which makes more sense to me.
Examine if on, right?
Yeah, if it's in 5000. But in here, in the 500, they call it examine if closed, okay?
Okay, yes.
Yes, and that means I'm waiting for something to close.
Okay.
And the second one here is examine if open. So if it's unenergized or open, that's going to light up. I'm waiting for something that's not energized in order to do it. So the reason it doesn't come on for all of them is because I'm specifying a certain bit level or point of contact right here. So each point of contact is considered a bit in the deal. So I just want to make sure we understood that. So in other words, I'm going to create something here, the stop start for maybe a motor coil or something like that. And so what I want to show you is I'm going to right click on this once. And now that is the symbol for a normally closed momentary button. And that is a stop button. Stops are always in the closed condition until you push on them, right? So I'm going to put down here And you can highlight this and click on it, or you can drag it until that square turns green. Either way you want to do it, you can. And what I do is I just highlight and I click and it puts one next to it. If I highlight, click an output, and we want to use the energize, not latching and unlatching. And then I'll throw the output way over here. And so when we build these things, just remember, inputs are to the left, outputs are to the right, okay? No input should ever go to the left of an output. And you never have two outputs in series. They're always parallel. And remember, outputs can only be on one line. It can be nowhere else in the program, okay? Because if it is, it's going to conflict and it won't work at all. Because one's saying on, one's saying off, it's not going to do anything. Now what I'm going to do, since I'm in my users, I'm going to create the loop under here to get the latching mechanism, or memory circuit as we call it. And I'm going to put another examine if closed in here. I have no examine if opens, even though I'm going to have an open push button and a closed push button. And I'm just going to use a light for my output. So if you're really want to do work, you can type all this in I:0/00, or you can just grab this, drag it up here. When it goes positive with the plus on it, release it.
Nice.
Yeah. And then what I do is I make my students right then and there so they don't forget. Right click. In this case, you edit symbol, but in the real one, I do description. I don't use symbols in 5000. And I'm going to call it stop.
And edit. All right, cool.
The next thing I'm going to do is I want my start, which is a momentarily open contact. So it's normally open momentary, which is this one. That's the symbol for it. Grab the address, sorry, grab the switch. Grab the address, and when it goes plus, bring it up there. And you may have to do it a couple of times to make it work. Looks like Shirley jumped out and back in. I guess she lost channel. I'm going to hold up until she gets back on.
Oh, I didn't know I was out.
Oh, well, it showed you pop back in. It says admit you, so I went ahead and it readmitted you.
Oh,
Unless you got
okay.
a
I
twin
didn't know.
somewhere. I mean, yeah. All right,
What's
so if
going-
you've got the second one up there, again, I always make my students come in,
Yeah.
edit symbol, put start in there. Oop. If you can type. And then the last one I'm going to do is the first light, just to have a light on, showing that I am in a motor situation. And I'm going to right click on that one. And I'm just going to call it, a lot of times we just call it M coil. So I just put an M in there because people will know what that is. It represents a motor. If it were a fan motor and I want to be specific, I could put FM in there, or, pump, PMP, something like that. Just take out your vowels. That's basically what you're doing. You don't have a heck of a lot of space in there to type. You can't put a book in that unless you're doing run edits. Then you have to do book type stuff. So if I want to latch this on, all I have to do in a real world, we'd have a motor contactor here with an overload on it. And then on the side of that, we'd have auxiliary contacts that would lock it in. But it's still part of that coil being engaged. So in PLC, you just use the same address as your motor coil and you drag it over here. And now when this closes. And so if I have this is normally closed, which I want it because stop, I need it to be closed. And I push on this closes that. When I release, this is now closed and my path is locked in. So it's a memory type circuit. It holds its value until I hit the stop. Okay. So if you have this in there, what I want to do is the little icon that looks like the refresh, flip it over and then hit download. Does its little thing and then put it in run mode. And what you're going to see is this lights up, the first one, right? Because it's looking for a closed contact. And look what I got. I got a stop, which is closed. The only way this one's going to go is when I push the button, it'll close, and then this will close, so it shows energized, and then this will close, which shows closed. So if I hit the button, it's now locked on. That's a basic start stop with missing one little thing, and I'll talk about that here in a second. And then if you hit your stop, it opens it back up. But notice that examine if closed. I'm only looking for something that's closed, and that's how it is. All right. Any questions about that?
No, thank you, Sam.
All right. That's just a kind of a quick review. I'm not trying to, be redundant or anal about this. I'm just trying to get you to show how it is. So in
That's
relay ladder logic, in the real world, you have an overload below your contactor, which makes that combination of those two is called a starter, right? So when you do that, you have to wire through the overload into a normally closed contact, which is buried on the overload. And you have to get in there and wire from the back side of your coil to that, out and back to the neutral or whatever you're using. If it's, the 0, if you're 24. And so when you do that, that has to be part of the circuit. It also has to be part of the circuit in the PLC. However, in the relay ladder diagrams, it is behind the output. It is not in front of the output. It is behind the output. Shirley, are you still on? Because I've got something acting like it wants to bring you on board here. I'm just gonna see if I can. Boy,
There's
I'm
another
gonna
Shirley.
try. I don't want to remove you because if I remove you, I think it's going to take you completely out of thing, and you won't be able to get back in. So I'm just going to leave it
So
alone,
what I did, see, I pulled up another screen so I could see you on yours, but I could do it on
Oh,
mine
maybe
on the
that's what that is.
That's
Okay,
what it
okay.
is.
I
That's what I
wasn't
did.
thinking. I wasn't thinking about that. You're right.
Because my
Okay,
screen is too little to see
I'm
you
good.
and do.
Yeah, I'm good. All right. So you can't put that input behind an output in order to knock it off. So what you have to do is you would have to come, and if you just roll this over without going to program, it automatically takes you back to program, and you're right back to your bits. What I normally do is I would put that normally closed contact right here. I would pick up one of these, like this switch down here. I'd close it. Oh, heck, I hit the wrong thing. Get it back up. I would close that switch, and I would use that address to signify for right now, because we're doing simulation. And I would have a examine if closed wired from that overload closed contact to the PLC. And I would call it OL for the overload. And that means that my overload on the bottom trips. It's going to take this out so it doesn't just automatically start up when you put power back on.
10-4.
That's a safety thing you have to understand. But in relay ladder, it would be the other way around. You'd have all of this, and then this would be behind it, because that's the only time they allow an input after an output, because what it is, that output and input are one module. That's all part of that module. And so it's a starter. So that's the only time in relay ladder you'd have an input after an output. Otherwise, the rules follow exactly like PLC. So I tell you this because unless you understand relay ladder logic, it's very difficult to understand PLC ladder logic. The way I do my courses in this, as you guys start teaching it, for them to get that, you don't necessarily force them to take motor controls one semester and PLC the next, although you can if you want to do it that way. I correct my motors and controls with my first level PLC, because there's a lot of overlap with relay and PLC ladder logic in that. And I make sure they're getting both as they go through. The issue you're going to run into is the old school guys that are relay ladder logic minded, that we grew up with it. I'm one of them. I had a hard time switching over to PLC ladder logic because this is a normally open contact, but I'm looking at it closed. It makes no sense. It's backwards. Feels like
Exactly.
it's completely backwards.
Exactly. That's been my hang up.
Right. So,
Finally getting it.
yeah, if you're not sure, and there's a couple of programs that you're going to run into that you're not sure if that sensor is open or closed. In this simulation, in the real world, you go out there and look at it and it'll tell you what it is. But in a simulation like this, just put one in, whatever you think it is, and then just go ahead and go on, like, download it and go in without doing anything. And you'll see that thing either light up or not light up. And you'll know if it's in the normally open or closed position. That's one way you can do it in the simulation
Yeah,
if you're
that's nice.
stuck. Because a
The
lot of
yellow
times
highlight is great.
yeah,
It is.
they
Yep.
won't tell you. Some of them they will not tell you, and you have to figure it out. And we're going to hit one of those in the next, not this meeting, but the next one. You're going to see it. So this is just a basic overview of what we did. And then the other thing we learned was timers and counters. And we'll come back to that a little bit later on. But I want to get this piece because this is what we're going to do with the door. There is one more thing I'm going to tell you. If I had a control relay that I wanted to cut something on, in other words, I want to cut more stuff on, but I don't have enough auxiliary contacts, I would bring in a control relay that has contacts all over it. Use that in conjunction with this. In other words, I could loop it down here and go. But if I do that, I have to physically go out there and wire another control relay out there. Or the beauty of the PLC is I have 8,200 relays built in that are virtual. So if I only had one contact on this and that's the only one I've got and I can't use any more than this, then what I got to do is I've got to go back out. Unfortunately for you don't have to really technically do that because this has infinite amount of contacts. I just create another one down here to do something else. So for example, if I came over here and I said a normally examine if open, and then I put an examine if closed over here, and I add a couple of more lights on the back end of these, I can turn lights on and off depending on what I want to do here. I'm just clicking them in. So what I did is I brought an examine if open, and I have an output for it. And I got examine if closed, and I brought an output in for that. And the key behind this is that these are also associated with this. So I can just drag that address down. I don't need another control relay. This is the beauty of the PLC. I eliminated wiring an entire set of control relays to do this. That's the beauty of this. Okay?
Yeah, this is it. This is the key right here.
Yeah,
Obviously.
yeah. Well, that takes that 5 walls in your room there of relays and brings it down to one PLC. I mean, huge difference. And troubleshooting is 10 times faster, 100 times faster. And then I just cut on, say, when it's not running, everything is good. I can bring one in here, the next output. And what I want to do is I'm going to right click on the light and make sure it is green, which mine are. And then I'll come over here and I'll edit the symbol. And I'm old school. We used to call lights pilot lights because it was like flying an airplane. You had pilot light, has lights in there. Today the kids are lights, so you can just put G light or whatever, but I use GPLT for green pilot. That's my terminology. I tell them use your terminology, use light. And the next one I'm going to put on, I want it to be a red light because it's warning I am running. So I'm going to drag this over here and make sure it is red. It is. Okay, good. I must have done this before. And I'll put RPLT for red pilot, like that. That's just another way. You don't need to drive another control relay out there. You don't need to wire it in. The only thing I'd wire in is my stop, my start, my coil, my overload, and 2 lights. I'm done. I walk away. There's none of that memory circuit wiring that takes forever to do and all that. It's already done inside the PLC for you. Big, huge cost savings. And then if you add an HMI, a large HMI out there, you don't even need to wire the lights because they're all on the HMI. And that's what I'm gonna try to figure out how I can make that work in the next class because I have enough HMIs to show you guys that. But we'll see what we do. And I got to work with Marilyn on setting up the next class. But I'm hoping to do it in December when everybody could, right after your classes, if we can do it. That would be good. And by the way, we don't have to host it at my location. If y'all want to come to my location, because it's more central, at least to you two for sure.
Yeah.
But we
Fine.
could do it either at HCC or over there, Tim, in your location, or somewhere else if y'all want to do it. But mine's
Earlier.
kind of central to all of you, so I just kind of felt like it's easier
Yeah.
to come to me. Yeah.
Makes sense. Surely it's kind of between us.
Yeah. Yeah. And actually it's same Sam's the only one that had to drive 100 miles, you know.
Where's he at?
200 miles. He's down in Sarasota, so he's below Shirley and them.
Yeah.
Yeah, he's a little ways away, but he's okay with it. I've talked to him a couple of times. He's just happy we're doing something. All right, let's flip
Hey,
it over.
one quick question, Sam. When you said you had the color, and what did you, on the
Right
simulator?
click on your light,
Got
right
it.
click on that, and you'll see the different colors.
Oh, okay. I just missed that. Okay.
Yeah, the first one's yellow, and I always keep my motors yellow or white if I had white, but this only has yellow, green, red. Now, when you do click on it, I can set all lamps to whatever color, or I can do individual with the lamps, which is what I do.
Perfect.
Yeah, that's just showing you that this is green. So if I go to 2.1 and I right click on it, you'll see I have it set to green. And then the other one I have set to red. And that's why I called it RPLT. Well, I didn't do that one right.
The simulator's sharp. Yeah, it's nice.
Yeah, it's good for practicing. And
Yeah.
this is not your training mechanism by no means.
No.
The drawback to this one is it does not teach them how to connect and
Exactly.
communicate.
Yeah.
It automatically communicates and uploads with you. And that's the drawback on this thing. What I really love about this PLC, you can show them programming in this. Then when you get out on the floor to a live piece of equipment, you can show them the communication process. But the good thing about this all has tricks to programming, which you guys are about to discover. And here you go. Now roll it over. Oh, sorry, roll it over, then hit download once you got it built. When you hit run, what's not on? If this is not on, the green light should come on and the red light should be off. There you go. Yours should look like mine. I have a green light on and that's all that's on. And if you hit the start, it'll go to red and the motor's running. Do you see the yellow and the red light on?
Yep.
So you've just created something that the operator, whoever's walking by, can identify whether that motor's on or not. Yeah. And then if you hit stop, it goes back to green because we made the motor coil that we wired into, and not only do we make it a motor coil, we made it a contactor, so we have extra, you know, kind of or actually a relay where we can use to put in as many. I could put 400 of these inputs, different styles down there. It's not gonna affect the programming. I'm using it so when that motor's on and I have this other thing going on, I can cut something else on. I can reuse the inputs over and over and over down the line. No magic to it. I can put as many inputs for this motor output down these programs as I want to. So what I'm just showed you is an output can now become a what?
An input.
What is this? An input. An input can never become an output. So you're going to have students thinking they can do that. And I have that trouble all the time. I tell them, no, remember we talked about this, you know, inputs can never be outputs. But outputs can become an input because there's contacts associated with them. So they can become an input based on their contacts. All right. Now we got that done. The other thing I want to talk about before we get into the next one, because you're going to need to know this, is your binary table here. These are the internal relays that you have. I do not need to go out and wire a relay for anything. What I need to do is just have a contact in order to run somewhere, and I can do that virtually. If I make this single one here a control relay, I can put as many inputs and inputs I want, but I can only have one of them as an output. All right. And a lot of times, as we roll forward, we're going to be using the B3s as your internal contact, so I don't have to go out and wire another control relay. That was the really biggest thing that the PLCs brought to the table, is now I don't have to wire to anything. I can do it all internally. In the real one, when you do the bigger units, they have B3:0 through 255. This one won't show 255 because it's a simulation. But there's another set of internal relays. It's called B10:0, and there's 255 of those. So you almost got 8,200 relays you can play with infinite amount of inputs on them. I mean, sky's the limit with this, right? It's pretty cool. If you move to 5,000, you have an infinite amount of internal relays. You just build them and then they work. It's pretty cool. So there's a whole lot you can do with this stuff here. And this is good to get them started. And I'm going to tell you, if you're not teaching 5,000, you're going to need to roll into that eventually. But for now, majority of the plants are still 500. So people go completely away from 500 and do not show the stuff we're going over now. They're hurting their students because the students are going to run into it and not know how to program it. It's going to look similar, but no tags. You got to manually do everything. It's a little bit different, okay? And it's going to throw them off. Or if you do strictly this and then they have to go do tag based and they don't understand what that means, it's going to be a little difficult for them too. So I show a little bit of both. All right, let's stop here. What you can do is we can just start a new one when we're done. You have to be in the program mode, right? Sometimes it'll let you close it out here. And then you can start a brand new one by just hitting the new tab. And then just hit the first one. We're in emulation here, so that's kind of what we're doing. Then I right click in the middle of the screen somewhere to bring it down. And what I want to do on that is switch your simulation. So have everybody got to this stage? Are you following me or are you behind?
Yeah, I have that open. It's hard because I only have the one screen, so I'm really watching you.
Yeah. So watch me and then
Yeah.
go do it. That's the
Yeah,
kind of
I
thing.
have it. I'm trying to toggle and look for pins, and then I can go back and watch yours. But yes.
Yeah. All right. So let me know if I need to slow down though, because I want to make sure you get these key points.
Oh no, this is great. Good review.
Yeah. So now what we're going to do is we're going to go into the door simulator. This is the one I wanted you guys to work on. It's not complicated, but it can be. Now, Tim, you don't have another screen, so this is going to be a little complicated for you too.
I'm going to do a lot of watching, and I'll go.
Yeah. So what I want you to do is just not do anything and look at my screen when I go into this. Okay. The help has the student exercises. When I click on the student exercises, they're web pages of them. There's a web page of them. So when I click on that, I'll use Edge, I guess. Simplest way to do it because there's no way it's going to happen. And they're web pages. I'm going to open this up, take up my screen. Can you see it or no? Are you still just seeing the Logix Pro, or are you seeing the?
Yeah, we're just seeing the Logix Pro.
Okay.
But I know what you did.
And I'm going to stop the share. I just want to because I want to go over it with you.
Okay. Yeah, I've looked at all that, but that's cool. Yeah, please do.
Yeah. And
we're in no hurry. At least
yeah.
I'm not.
And introduction exercise is the first one, right?
Yep.
Door simulation. This is what we just did.
Yep.
And then here is the relay ladder logic or relay logic. So this is your door simulation. What I have my students do is go through this and I walk them through the beginning of it. And then what they do is they turn in the very last exercise here. That is all I want them to do. I don't care about the rest of them because if you do, you have to do the rest of them in order to get this done. So they're going to do all the exercises, but it culminates right here. This is like the finished product of the other 3 exercises. So I only have them turn in this one exercise, and that's it. I'm going to go through this step by step because you want your students to do the same thing if they're going to use this. And I did not put this in my bookstore, this software. The students physically have to go out and buy it. It's
All right,
that
that was my next
$38.
question.
They're going to spend that. And I don't use it until to the point where they have to start learning how to program. And they got to get through what is a PLC, some of the numbering system and all that. So it's about 3 or 4 weeks in before they even start programming. So that gives them time to get their financial aid dollars in their pocket, go out and buy it, or wait for their next paycheck to go out and buy it. So I'm not using it day one. So that's kind of thing there. So in the door simulation, the first exercise, I'm just going to read through it and then we're going to go do it. So in this exercise, the open and close buttons, right here, the open and close buttons right there, will be used to control the movement of the door. Movement of the door will not be maintained when either button is pressed. Therefore, we don't need a stop switch. That's what it's telling you. However, in order to, we do have inputs and outputs that are going to be employed. So by pressing the open and holding that open, the door moves up, okay? And then it'll continue as long as I'm holding that down. But if I release it, it's going to stop. And then releasing of the, or if the limit switch LS1 opens, then the door is going to stop. And we're going to talk about limit switches because students get this really confused, very much confused. And then the same with the close. We're going to go all the way down until the LS2 has made contact and closes. This is going to give you a chance to understand the examine if open and examine if closed things. And that's what this is designed to do. And under no circumstances will both windings, so you have a forward reverse, right, on the motor. So you can't engage the windings together because if you did, you would burn the motor up completely. And it will catch fire on you if you did that later on in the program. You know, sirens go off, all kinds of crazy things. And so the open lamp will be illuminated if the door is fully open, not partially, but fully open. Same with the closed. If it's fully closed, it'll come on. Otherwise, it's not going to come on. So here's my big one. I do not allow them to use the latch circuits to hold the thing open or there on any of it. Even though down below they say you can try to use the, I tell them no, I don't want them to use latch and unlatch yet. It gets real confusing when they start doing that because they won't learn how to do the memory circuit style programming because they're going to have to latch on stuff that you have to use a latch function, an output that has a latch on it, and then somewhere down your program, you have to unlatch it at some point. That could be 500 runs down. I don't know, but if one of them, if they're both engaged or both off, it will not operate. And that is so hard to find. And I have to look for 2 different, outputs somewhere in here to figure out what's going on. And you can't see them simultaneously, so it's a little hard. So if you put it on one and use the memory circuit, I only have to look at one line to figure out what's going on. For troubleshooting purposes, I only use latch unlatch personally when I'm doing something like an elevator where I have a call. I'm calling some position somewhere. Then I'll latch a bit on to hold that position as being called. Otherwise, I don't even use them. It causes more trouble than it's worth. But I do have a couple of projects I let them use them in just so they can understand what they do. But other than that, I don't use them. So that's what we're going to do. So what I'm going to do is I'm going to switch back over to the other one. Go back to the Logix Pro for you, since I can't go to desktop for some reason. And I'm going to go ahead and talk about what we're going to do. So here is everything. We have 3 lights. We have 3 inputs here, and we have a couple of more outputs here and 2 more inputs over here, right? Here's what I was telling about. How do you know what these limit switches are? Are they normally open or are they normally closed? Normal being not touched, unenergized, right? So if I mouse over them, these are normally open. Activated true when the door is fully closed, else activated is false. It means it's not contacted. It means it's normally in its normal position where it's not being held like the door is on this one. Then it would be set up to be open contacts. That's what they are. When the door hits the switch, they are now closed contacts. So in the position these two are in now, they are closed because they're being pushed on, okay? If the door was not on this one, it was halfway up, this one would be open, this one would still be closed. If this door was all the way open, both of these would be open. Or like they are now, if it's all the way closed, both of these are closed contacts right now. So you have to know what I'm trying to do for examination. And that's the key behind this one. All right, let's get started. I'm going to build a simple stop start like we did a few minutes ago. Okay, I'll highlight this, roll this over to the contacts that I can use. And the stop is always a normally closed contact. You see it's normally closed push button. That's the way they always are. So I'm going to look at it at close because I want it closed. And then this should be an examine if, or normally open push button. They're momentary, which means as long as I held them, they're closed. And that means that this one also, I want to wait till this is closed before I open the door. So I'm going to look at that one as a closed input as well. And then I'm going to put the motor up as my output. Click on it. And then I'm going to do exactly what I did before. In this case, you grab the address on this one, drag it up here, and when it goes plus, take a moment to go ahead and label it so you know what it is. And then I'm going to do the same thing with the open. I'm going to take this one, come up here, right click, edit symbol, and I'm going to call that open, just like it lay labeled there. And the reason you want to do that is anybody coming behind you in the program knows that's an open switch, and there's my input open, so they know what it is. That's all I'm trying to do. And I could put PB behind it for open push button, because I also have an open for a light. And what I usually do is put open PLT or LT for the new students coming in. They just call it LT now. And that's what we'll do on that one. So I'm going to move my motor up address, just like I did the other ones. When it turns plus, release it, right click, edit symbol, and I make this short, M up. So I know it's motor up. I'm not locking this in. Remember, they talked about not locking this in. Also, they said, really, Sam, you don't even need the, the stop. I'll cut it. I don't need it. I put it in there to do a stop start, but I don't need it because I'm not doing momentary. This is your exercise 1. Thing they said last was, if that door is opening and I'm going up here, this has got to stop when this opens up. So what condition do I want it to be in when I'm moving up? I want to examine if open, or do I want to examine if closed? This is the question the students need to understand.
All right, say that again.
So I've got the open and I got my output to move the door. As long as I hold that open, it's going to go up, but I don't want to go up past this, because if I held this down and I didn't stop it when it got top, the motor would burn up, catch fire, all that, because I'm still running windings that can't move. So I want to stop it when I get to the top limit switch. But in order to get it up, move it up, what condition is the LS1 going to be in?
It's
What do I have to put in there to make it go?
Gotta be
Yeah.
closed to move up. So normally,
Examine if closed. Do you
Yeah,
understand
sure.
that, Shirley? Why we said that?
Sam, I have a simple problem here.
Okay.
When I clicked on my screen and it made the ladder logic area very large.
All you do is
I,
right click, watch. Right click on my screen, right click on my screen.
okay, let me do that. Okay, let me go back. All these screens. Okay, right click on my screen.
And it should bring
You're
back the
right.
simulation.
Yes. So, oh, yeah, yeah. It's simple,
Yeah, it's
simple,
the
simple.
little
Okay.
things in life, you know.
Oh, goodness.
Yeah, it is. It is, man.
It is.
That's fun. When you see that, you go like, all right, I didn't know that could happen. I love it, man. I love when that
Right. I'm
happens.
like, how I lost my screen. So, okay.
Oh, your screen may be down the bottom down here somewhere. If you
Yeah,
like, if I
I had
drop it
just,
down. Okay. Yeah.
I got it from when you
Okay.
said you just right click on the screen, brings it back. Okay.
Right. 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 Okay.
Where
So
were we?
we were talking about what condition this limit switch has to be in order to make this go up. So normally it's open, but if it's activated, it becomes closed. So what Tim was saying was in order for that to go up, that you have to make that limit switch closed, because when we get to the top and it opens, it's going to stop the motor from running. So if I held the button past where it fully opened and I didn't have that in there, I would burn the motor up. So I have to have that limit switch in there to stop the motor when it reaches the top so I don't burn the motor up. Okay, so it's in the closed position right now. That's where it has to be in order to move the motor up. So I'm going to bring its address over here, and I'm going to right click and go LS1. All right, we got that. Now what we want to do is test this part of it. You don't need to do everything, okay? You test this part of it just to make sure it works. This is what I force my students to do. Every little thing you do, run out there and just do some checks on it, test it, make sure it works. If they can. They may not be able to do it at this point, but if they can, they want to try to test it. Notice that the LS is lit up, right? Because
Yep.
it is in the normally closed. That's how I would know I did it right.
Perfect.
Then if I hold the button, I'm going to speed mine up a little bit because I have mine set low because I had another student with a very fast computer. Yeah, I'll go a little faster than that. That's too slow.
Perfect.
That's going to go up until that limit switch is going to stop the electricity from flowing through in the program. Boom. Do you see that? It
Yep.
stopped because I have the limit switch open, and so now that's no longer a signal. So my electricity flows through. It is no longer flowing through there because it is. So if I hit the open closes, but the limit switch not being closed won't allow power to get to this. So this is my L1. If I was looking at a relay ladder, this is my neutral, or it could be 24-0, however you want to do it, plus minus. That's the way my electricity flows through, like this. So if you look at it like that, that's what happens. I can't go past the limit switch, so it won't move anymore. I'm going to do the exact same thing going down. So I'm going to roll it down, roll it over, start on my next one. I know I've got a close button, or shut button, I guess I call it. It's going to be, no, it's closed. That button is normally open as well. So I want to examine it when it's closed. I'm going to bring an examine if closed in there. And then its limit switch, when it's coming down, what is the condition of this limit switch now?
Until it's open, until it gets
Right. So in order to go down, the only way I can move down is if that thing is open, right? Because when it's fully closed, that thing is closed. So I have to examine if
open.
correct. So
And
the next
this
one
is
I'm going to put in here.
Here's the
Right, is gonna be
confusing part. It's the closed contactor. That's what kept hanging me up. It's always
So, and believe me, it's locked in my head that way. Still to this day, it's locked in my head. But I had to relearn what that means, and it took me a while to get there. Wasn't
know,
easy when I first started doing this, and I was in the old DOS version of this, so it was
well,
ridiculous
this
back in the
simulator is so nice. I'm telling
80s and 90s trying to figure this stuff out. With there was no training unless you went to Allen Bradley or something. And I didn't have the money for that, so I had to figure it out on my own. And then I went to Allen Bradley training. Yeah. That's how I did it. But at any rate, so right here, this one is your close. Close. So I'm going to bring the address over here. Right click on it, edit the symbol, and call it what it is. Close. And I can put PB if I want. And then I'm going to take this limit switch down here, which controls when I'm closed or not. I'm going to bring it up. And we'll right click on it, and I'm going to edit symbol. And I'm going to call it LS2. Limit switch 2. And then what I'm turning on is the other winding, which is the motor down. It's actually the same type of winding, but so I'm going to bring that output in behind here. And I'm going to use the motor down output over here, and I'll call it M down. Right. And I have my motor up, my motor down. I'm good. And all I have to do now, once I get that set up like this, roll it over, download it, put it in run mode. Notice one limit switch is activated, one isn't, because this is open and I'm looking for it to be closed, not activated. This one is open and I'm looking for it to be open, so it's activated. So it's allowing things to pass, electricity to pass through. So when I hit the close button now, you can see how it's going down. Stops down there because I broke the circuit right here. I'm no longer open. I'm now closed. So, but I'm looking for it to be open, so it's not going to read it if it's closed. So remember, when I do this, the way the PLC works is, and this is all done in 160 milliseconds. It scans the input table, what's on, what's not on. Then it scans your program. What do I want on? What do I don't want on? And I need to set these outputs accordingly. And then it scans the output table and sets those outputs based on your program. All that in 160 milliseconds, faster than you can blink your eye.
Hey,
So it
Sam,
looks
why is the
instantaneous.
scans jumping
What's
currently?
that?
If you look on the simulator, the scans changes. It goes 197, 205, 194. What?
Oh yeah. That's
What?
what it's scanning. Yeah.
So that's it's actually telling you. It's okay. All
Yeah, that's how many scans it's got then or something. Silly thing. Yeah.
right, thanks.
So that's what it's doing. So now you can open and close at your leisure. So if you go halfway up, I got one open, one closed, so they're both lit up. Do you see that? And if you go all the way up, it's going to be the opposite. Bottom one will be on and the top one will be off. Simple as that. So what I'm going to do now is I'm going to do something to show you what's going to happen when you don't have what you need on there. So I'm going to stop it for just a second. I'm going to cut that out because if you haven't experienced this, you've never lived. And this is what you're going to hear in your classroom as they're working on this stuff. If you can hear it, you may not be able to hear it because of the I'm on my headphones, so I don't think it's going to come through. But if you do this, you'd hear it on yours. Did you see it catch fire? And then a big sirens will go off. Mine's delayed right now because I've got stuff in the background running because of Zoom. Everything is delayed. I'm still hearing it click like it's closing. Here in a second, it'll start. The alarms will go off and all kinds of fun things. Okay. And then you just hit clean up. It resets the simulation for you. and you're ready to go again. And then you just put that back in there in order to do it. Okay. So I'm gonna, and you'll hear the car start when it's reset. That's the cool thing. All right, I'm gonna flip it over, put that back in because I shouldn't have done that. And then bring this one back in. One more thing they told you to do in this one. The two windings cannot be energized simultaneously, or again, it will burn up. And you're going like, well, I'm only pushing one button, but you're going to have that joker in the, in your facility that wants to push both close and open at the same time. And see what happens. There's people like that out there. So what you got to do is I've got to interlock the motors. That means when one motor is running, the other motor cannot be running. Okay, that's what that means. That's interlocking my motors. So let's look at the first one. If I'm running through here and I want this one running, this has to be in what condition? Open or closed? Look that motor up. For this to move up, what condition does motor have M down have to be in? Energized or not energized?
Open.
Open. So I'm going to bring an examine if open here, and I'm going to drag this address up to here. And what I've done is I've interlocked M to the down motor, but I haven't done the down motor to the up. It's the exact same thing going the other way. Motor up will also need to be open in order for me to push the down button. I'm going to add that in on this one.
Okay.
And I'm going to drag its address over here. And I have officially interlocked the motors PLC wise. Now, Tim's familiar. You're familiar with the forward reverse, right?
Yeah.
What are you going to do on a forward reverse when you're out there? You're going to interlock the motors mechanically, right? Because you have that little device that goes between the two contactors, right? They both go to the same overload. So there's a mechanical device that locks one down so the other one cannot be on. So if I hit one until I stop it, the other one will not go done. And that's done mechanically with a little thing in between them that blocks one when one's going, the other one can't go. You also have contacts you add on there that are normally open and normally closed. And you also electrically do it in the field where you're doing the forward reverse. You do not allow the forward reverse to do it electrically. So you're redundant. You got a mechanical and an electrical wiring situation that you do that with. Not only that, but you're going to come into this PLC and do it too. You just don't want those two to ever come in. So this one would be the normally closed contacts that you're wiring in from the auxiliary contacts on the starter. Not the overload ones, but the auxiliaries that are up on the contactor themselves. What I do is I add in a set of contacts or a relay, depending on the type of starter I have. Using the square Ds, they don't have auxiliaries on them. So you have to add a relay out there to do it with. But the modern versions have, like the modern Allen Bradley stuff, they have where you can actually on the front of it clip on additional contacts on it. So you can add more of these on there if you want. And I use the normally, I guess, closed contact to wire in to examine if that's open or something. And if it is open, that's great. I'm going to use it. But, I would wire those in. So now not only do I have it wired out there in the field possibly, I don't have to do the wiring part because I'm going to do it through the PLC. I still have the mechanical one out there. So either way, I've got two backups on stopping that from interlocking. Students need to understand that. That's why I run these two classes together. Motor controls, and here we are doing the same thing in PLC. Now, what did you do over here? Okay, now you're just going to wire it directly to the PLC. You don't need to do all that fancy wiring through the coils and all that. So that's what we're trying to show them, that this is a better way, and that the old motor control wiring, even though it's still prevalent, and if you don't have a PLC, you got to do it that way. But also, you want to do it with a PLC. That's really what you want to do.
Yep.
All right, now we got that done. I want to look at what the next one says on there, and I'm gonna just open it up for me to look at. If you went to your second one, I would tell you, I'm not gonna share the screen this time. The door movement will be halted immediately when the stop switch is pressed. So we have to add in a stop switch. Pressing the open will cause the door, if not already fully open, the operation will start to open, even if the switch is released. So now we're doing our start stop memory circuit kind of stuff. Same with the closed. If it's not already shut, pressing it will allow it to go down, and when you release it, it runs. And if the door is fully opened, it's not going to go anywhere. If it's fully closed, it's not going to go anywhere if I hit the open or closed, respectively. So if I'm already open and I hit the open, it's not going to go anywhere. If it's already closed and I hit the close, it's not going to go anywhere. This time we're adding in lights. We're going to do the ajar lamp is illuminated if the door is not fully open or fully closed. Also, the open lamp will be illuminated if the door is wide open, and it will be closed if the door is fully closed. And so let's make that happen. I don't know what it all is, so I will show it to you. I'm actually moving mine up to my other screen there so I can make sure we hit all the points here. So I don't require, but I make it optional to my students. You need to have a dual monitor to do this stuff. They can watch me on the screen in the classroom and have theirs. That's their dual monitor in the classroom. But when I'm online doing this stuff, because I do my lectures online a lot, and then because I can record them, even in the classroom, I'm recording everything. But then we do it live in the classroom. They're right there with it. All right. So here's what we're going to do. First thing I'm going to do is it said you're going to stop the movement with a stop. So now I'm going to add my stop into this. So I'm going to highlight my first run, and stop is a normally closed like we did before. So I want to look at it closed. So I'm going to go examine if closed there. Put one down here on the second one and put examine if closed there. And I'm going to move the stop in to here. And I'm going to bring it down to here. And there it is. Got that part done. I'm good. Well, what did they tell us? When you release the open, it continues opening until it gets fully open. So now I got to add in my start stop situation. My start in this case is the open or it is the close, depending on which direction you're going. So I have to add that little loop thing into there. So the other branch run. So I'm going to put the other branch run in here. Right in front of this one. And in the real world, you can drag this around, but this software, you have to drag the bit in. That was one of the things he did to keep from getting sued, I guess. And add the input to latch it in, and I will drag this one. Has to match my output right there. I have created my stop start on my open. I need to do the same thing on the closed. What I'm going to do is I'm going to drag my little rung branch down here, move my closed inside, come over here, add another examine if closed input, drag my address for that output in here, and now I have created the memory circuit for this, or basically a stop start for this one. At this stage, I want my students to test the operation and make sure it's working before we get into the lights. Okay, we've already got it set up where they won't energize. They're basically locked out from each other. So they're interlocked. We've got the limit switches, so they won't go beyond their limits. And I added the stop and the loop, so let's see if that works. Simply by flipping the little refresh arrow over, hit the download. Anytime you make a change, you need to put a download in. And then I'm going to hit run. I'm going to hit the open. Watch it go on its own. I'm not holding it anymore. It's just flowing up. Until it stops. Now, if I hit open again, won't go anywhere because my limit switch has got it blocked from going any further. So I can't burn that motor up. Now, if I hit close, same thing. It's going to close until I get all the way down the bottom, and then it's going to stop. And it won't close anymore because the limit switch is going to block it from happening. Boom. Stopped. If I hit close again, now I'm going to test my stop circuit. I'm going to hit open. Going to get about halfway up there, and then I'm going to hit my stop to see if that helps. Yep, look at that. I engage my stop. That blocked the circuit, which knocked this off and knocked my memory circuit off. So now I have to hit open again to get it started. Same if I hit close. I hit close, then I hit the stop, stops. That is it. I am done with that one because I hit close or open, it's going to work. Doesn't matter which direction I'm going because I am not fully open and I'm not fully closed. So standing across the room, and I'm way down here, so let me show you. I may be behind here and I can't tell if that thing is fully closed or fully open. So in order to understand that, we have to add the lights on. So somebody across the room could see if the door is ajar or not, or if it's fully open or fully closed. That's where the lights are going to come in. So we're going to roll this over, or you can hit program and roll it over. And what I'm going to do is I'm going to add my lights in. Now, I will not add the lights in on these existing rungs. I make the lights separate. They're their own output and their own entity. So that's the key. Okay. Yeah. All right. Thank you. Thank you. Thank you. I just saw the message up there. Sorry, I didn't see it earlier. So what we're going to do is we're going to create the rest of the deal. So now what I want to do is I want to start with the open light. So I'm just going to put an output in there, and I'm going to bring the address from the open light in there. I'm going to be working on the open light, and I'm going to right click, edit, and I'm not going to call it open like I did my switch because that gets confusing. I'm going to call it open, and of course in my world it's PLT, what I grew up with. Open PLT, so that's my pilot light. And how do I know that that thing is open, fully open? What tells me that thing is fully open?
The fully open would be lever switch 1 is open. I mean,
Okay.
limit switch 1 is open.
So if limit switch 1 is open, means it's not being touched by the door, then I know I'm fully open. So that's what I'm going to put in there. Very good, Tim. Boom. And I'm going to take the LS1 address, bring it down here. And now I know when that door is fully open, that's the only time that light is going to come on. I'm going to do the same thing down here with the close light. So I'm going to put the output in there. I'm going to move the closed, the shut lamp. So then we'll call this one shut, just like it shows on the thing. And then what condition does this have to be in to know that it is fully closed?
Limit switch 2 is closed.
So I look at examine if closed.
Yep.
And LS2, drag it up here. Let me test this. I've got this far. Let me test it before I go any further with the jar lamp. Nothing's on, which is the way it should be right now, but I'm going to go ahead and finish closing. Watch. What happened when I fully closed?
The shut light's on.
Right, because I'm making contact with that limit switch down there. That's telling me that I am shut. And then if I hit open, I'm no longer shut. Now I'm open because of the limit switch.
Now we're going to add the ajar light.
Yeah, the next step now is how do we get the ajar light to work? Well, let's put the ajar light in first. Get that done. You know what that is. That's going to be right here. And I'm going to put in here a jar, like it shows. And what I'm looking at here is how do I know the ajar light is going to be on?
Both switches.
What condition is a jar light on? If I'm not fully what?
One's on, one's off.
What is on and what's off?
One of the limit switches. Let me think. How?
Okay,
Yeah.
so you're saying one limit switch is closed and one is open?
Yeah.
Okay, which is which though?
Oh, when it's a jar, the limit switch 1 is closed and limit switch 2 is open.
So we want to examine if limit switch 1 is closed and limit switch 2 is open. That's what you're telling me.
Yes, on the same run. Okay, that's okay. Exactly.
Right. Well, they have to be in series. Both of these, so I have to have the limit switch and the other limit switch in this condition. This is an and statement.
An and statement. Yeah.
Right. Most of this is and with the exception of the
You have the one or
right, because these are ors right here.
the
If
two.
either or of these are in contact, that's what's keeping that going. But this and either or of these and this, mostly we have ands in there. Or we have what we call the hex. If this, then that kind of thing. This is a not, this is the hex.
Yep.
Hex meaning that if it's engaged, it's something turns something on. That's all it is. Okay, so we got that piece done. So you have an examine if closed and examine if open. So this is a hex and a not, and they're anded together, basically. So these two switches have to be in these conditions. When this and in that condition, and this is in this condition, I've got that. It's the basic logic. Okay. Now let's test it out. Roll it over, download it. And there. I am open. Now let me hit close. Notice when I'm closed, what's happening?
The jar light is on.
Right. As long as I'm in between the two limit switches because of this, I am now ajar. Okay. And my jar light's on. So if I'm across the room and I can't tell whether it's fully closed or not, and I see the ajar light on, I said, oh man, that door's not closed. Let me go close it. And that's what's going to happen. And when I go fully close it, the close light will work. So you've done everything they asked you to do in this one. Okay. This is this is good. All right. Now then.
Okay, Sam, what is the input output? I'm trying to figure out. It's changing. There's that little box and it'll tell you the channels and
This right here,
yes.
that's your PLC. That's your modular PLC out there. It's just flashing, showing you that things are changing in there.
Yeah, that's how it's just
So right now, what do I have on? I have this one on output wise. I have one on there, right?
Yep.
So channel is only have a 1 on my output.
Okay,
I'm in this slot because it's in the second slot.
got it.
First slot, it's got 1 input on, but actually 1CH. What is 1CH? What is that? What does the H stand for? Do you know?
Let's see.
In numbering system, what does H stand for?
8.
Yep. What
Yeah.
has numbers and letters? Which numbering system has numbers and letters?
Alphanumeric.
No,
What? Ask you what?
no, this is numbering system, not letters and printing. You have binary. How many is in that?
Binary's got 2.
Right.
The octal. It's octal. Okay.
It's hexadecimal.
Hexy, why? Heck, why hexy?
Hex
Yeah.
has 1, 0 through 9, then starts its letters.
Got it. Got it.
I am
Okay.
1 and a C. What
Got it.
is C? You know, and
Yeah.
then you look at the 1, and that's how many of these inputs are on.
Yeah,
If you're looking at the hexadecimal value of these inputs on, that's what
Yeah.
it is.
got it. All right. Yeah.
Yeah. I'm in the second
Which rattles me, yeah.
row with these. So this is only has a 1
Yeah, got it.
because I'm in the second deal there. And it's the fourth one over. I don't know if you noticed it's 2-4, not 2-0. That's what it is. So since it's 2-4, it's the fourth one over. That's what it's going to be.
Okay.
Okay.
Yep, thank you.
All right. Let me think about what else. Oh, I was going to look at the next exercise for you, and I'm going to stop after this one because we're already an hour in, and I know you guys got other things to do today. And I don't know how long we're supposed to be here, but I think it was like an hour maybe. But I'm going to go ahead and finish this one up, and then I'm going to make you do the last one. And when we get together, I want to see how far you got with it because that's the fun one.
All right, cool.
All right, we're going to play with our lights now, okay? That's basically what this is. So if the door is fully open, the open lamp will be energized but not flashing. We're already there, right? If it's fully closed, same thing. That's where we're at, right? If the door is fully open, the light's steady on, right? So right now you're shut or closed, so the shut light's fully on and not flashing. We're good with that, right?
Yep.
Okay. Now, if the door is opening, then the lamp is going to flash while the door is in motion.
Okay.
How are we going to do that? Tell me how you would approach that. I'm going to get back over to my programming side here on my PLC. How would I get this thing to flash while the door is opening?
When motor up's on, it needs to be linked to the motor up.
Okay.
But
So how do I do that? You got to guide me through this now. So this is on, it works. Or, so what's my or?
that or
Look
our
up here.
motor.
What generates the or up here?
Oh, our loop. We are branch loop.
Okay, bring that down.
We bring it down, set it there. Yep. Put in.
And what did you say earlier when what was going on?
When the motor up is on. When
Okay,
the
so that has to be on or examine if closed.
In the loop.
And so I'm going to
the
bring
motor.
the motor up down.
Yep.
And what it's going to do is it's going to flash. How do I get the flash in there? Remember we talked about this before.
Oh God, is this I quit.
It's in here.
Let's see.
Right here, your status bits.
Got it.
Your S24s flash. So watch when I go online right quick here. You see them flashing?
Yes.
I'm looking for about a second, so let me get mine down to about 29 is about normal speed for me. Even that looks a little bit. I'm gonna have to speed it up just a little bit because I forgot I got the thing on. There you go. Look at number 6. It's flashing about 1 second interval. Let's see, 1000, 1001. Yeah, okay. Maybe 5. Well, 6. I'm going to use 6 on this one here because that's good. So what I'm going to do is I've got to add that in there to flash it while this is on.
Okay.
So what I'm going to do is I'm going to roll over. I'm going to drop. It doesn't matter whether these are normally open or normally closed. It's going to be on whether it's on or off, right?
Okay.
Doesn't matter which one you do. I just use the normally open. I'm going to drag this address from this bit here over here. If you want to know how I got that, I'm going to roll this back out. If you hit up here the little tools, that opens up your data table. All you have to do is drop down till you hit your S2, and there you are.
Okay.
And what I've done is, while this motor is running, I am flashing at this rate. I'm going to do the same thing down here with the shut, except what am I going to use? Not motor up, but
Put motor down. So,
correct. So I'm going to bring a loop on the bottom one.
Yeah.
Bypass
Sam?
this.
Loop
Yes,
it.
ma'am.
I was supposed to, where was the tool in the status bit? Because I'm
Right up
doing
here.
more
See
to
at the
the
top?
screen.
Can you see up here at the
I'm
top
looking.
where I'm circling?
There you go. Got it. I missed it. Okay. So
Yeah.
there's the
Right. So what I'm going to do is I'm about to
Gotcha.
open it up again here in a minute.
Okay.
I'm going to go ahead and put two inputs like this in. One, two. And then what I'm going to do is I'm going to say when the motor down is running. Now I'm going to open up my little database up here and make sure I'm on S2. I'm going to grab mine. I've got mine because mine speed's different than yours. You just need to find one that's flashing at a rate that you can do. So if I set my scan rate, for example, at about 29, and I just look for the one that's flashing about 1 second, that's perfect.
Okay.
And then I'm going to go down. I'm going to use 6 in this case because I've moved mine around. And I'm going to go S246, drag it down. And notice it just goes S4/6, which is the shortened version of it.
Okay.
It already knows it's S2 for some reason. I don't know why it does that. Now let me see if that works. I'm taking this one step at a time because I don't want to confuse you guys. So we check very often on any changes we make. So once you have it set up exactly like this, and notice I'm using the same speed whether I'm going up or down, because when you do the ajar lamp, they want it 1/4 the rate. I'm going to show you how to figure that out. And what you're going to do is you're going to download this once it's in there. Cut it on. Nothing's flashing because I'm not in motion. But when I hit open and I'm moving up, watch the open light. Do you see it?
Yep.
Notice when I get to the top, it is fully on, but this is still flashing. Why isn't it flashing? The reason it's flashing for a couple of reasons. If I had this on and this on, it would still be steady because when this goes down, this is still providing power to it.
Mm-hmm.
Anytime you have a straight line power to the light, it's going to stay on whether something else is trying to flash it or not.
Mm-hmm.
You need to understand that because the students are going to go, well, mine's not flashing because they put something in there that's holding it on. That's a real critical thinking for these kids to understand that. Look, when this is on, I can either run it like this or I can run it like this. This is your example of your or statement here. This will cut it on or this will flash it, one or the other. You're either going to be steady on or you're going to be flashing. So if they accidentally put this in backwards and they're trying to flash when they go, it's going to be steady on because I've got a steady power to the light. It's not going to flash. And you need to understand that when programming because if you're trying to flash something and something else is holding it steady on, it's going to stay steady on. That's the point. All right. Now it's shutting it, does the same thing. I'll close. See how it is?
Yep.
My jar light's on. Isn't that nice?
Yep.
There you go. All right. Let's roll out of this. The next thing is your ajar light. What it says is the ajar lamp will flash if the door is stationary. It is not fully open, not fully closed position. The ajar lamp will flash at 1/4 the rate than the other lamps. Also, when it's in motion, that thing will be steadily on. All right. First one's easy. If it's in motion, that either means what's going on, my motor up or my motor down or what? One of the two or what?
They're contacted.
On, right? They're active. So if either one of them is active, then I've got that thing steady on.
Yep.
Also, I have to be in between these limit switches, right?
Yeah.
So this and whatever condition I'm on is going to happen. So watch what I'm going to do. I'm going to add another input saying motor 1 is coming up.
Mm-hmm.
If motor up, that thing's going to be steady on.
Mm-hmm.
Oh, by the way, if I'm going closed, the same thing. So if either or are done, then I'm going to put an or statement.
Okay, branch, yep.
All right. I'm gonna do the same thing on the bottom with the motor going down.
Mhm.
There you go. Now, if I'm in motion, that thing is flashing on steadily. It's not going anywhere. Unfortunately, if I were just to do this and nothing else, while I'm in between and stationary, I have no light on because I'm waiting for one of these to be open in order for that to go on. So there's a third option. When both of them are stopped, I am flashing at the quarter rate. So I got to put another loop in here. And guess what's going to go in here? If neither motor is on, that means they're open.
Mhm. Damn it, it's open.
I got a flash.
You gotta have much. Okay, I got it.
Right here, right here,
Yeah.
and I'm going to flash at a quarter this rate. So I'm going to
Okay.
show you what that means. I'm going to flip it over and just go on. I'm not going to do anything with downloading. But notice my 6.
Yeah. So go to your.
Every 2 times that flashes, this one comes on. Every 4 times that flashes, this one comes on. So this is half the rate of this. This one is half the rate of this one, or a quarter of the rate of
Got
this
it.
one. So now what I have to do is I can drag this down once I get offline here, and I can change it to the value of 8 when I'm done. Or I can just come up here and grab the 8. Either way, if you have it open, just grab the 8, bring it down here. Normally, I don't even look at that because I know a quarter of the rate's going to be too high. I just drag it down, change it to 8. Either way you do it, it's fine. Now, when I'm stopped in the middle, that thing is going to be flashing much more rapidly than the open and closed values. Let's test that out. Notice I'm shut. I'm going to start to open. My jar light's on that. I'm going to hit stop. It's not working right at all. I guess my S248 is slower. I need to go back the other way. Sorry, I'm in the wrong direction. We'll stop. This should have been 4. Sorry.
Yeah, because you went faster.
I went
right?
down. Yeah, I went slower. I should have
You
gone
went
up.
slower. That's yeah. So you should have went to
Yeah.
Yeah.
4 instead of
Got it.
2 down the other way. Now when I download it and turn it on, you'll see it flashing really fast.
It's good when I follow that. I know what's going on when I catch that little thing you're talking about.
Doing a quarter the rate.
Got it. Yep. That's it. Yeah. That made you.
Yeah, I could move
you
this to
take place there.
5. Yeah, I could move this to 7 and then do
Yeah.
or 8 and 4. Depends on what you want to do. Just to make it so you can actually see it flashing, but it is flashing.
Yep.
And then when I hit shut or open, now it's this one's flashing at a quarter of the rate for that one.
Yep.
Now here's the thing that for the next one, the last one you're going to do. I'm not going to do this one today with you. I'm going to see if you guys can figure it out. I'm going to give you some hints. I'm opening. What I want to do is I want to hit close, but I want it to stop when I hit close. And then when I hit close the second time, I want it to go down and close. That's what the last one asks you to do. You do not use latch and unlatch, okay?
Okay.
The reason I want to do it that way is I want to see if you can figure something out. So I am flagging a condition on that. Think about it in terms of, Shirley, did you get this piece done before I go any further? I don't want to leave you in the dust or anything.
My other computer died that I had it up that I was working on. So I was like trying to get it back up and it's gone. So I have
What?
you on.
All right.
I had 2 screens. Remember, I was working on it. So
Yeah.
I was screen that you are only doing it. So I just.
This is what I'm going to do. This is the program. And, okay, I'll just do it there. This is door. I'm going to see if I can do this. Okay, I haven't done this in a while, but this is being acting kind of strange for me. So let me get into the chat, and I am going to see if I can figure this out. Uh, on my computer, there it is.
So we can't save when we don't have the real program, right? We can
You
save.
can if you have the full-blown version. Did you buy it?
I don't remember. Yes, I did. Yes, I did.
Yeah, then it should be savable. If you bought it and you got your code in, you're savable. I have just go into the chat. I've sent out the door project I just did with you guys, so you have a copy of it. Y'all download that. I will send it over to. Well, I guess you can pick it up. I guess if you want to do that and distribute it to everyone. But I don't want the people who weren't here. I want them to try it first. So let's not distribute it until they have a chance to walk through with me
Exactly.
on watching the video and do it themselves. So only you two got the code because you were here. All right. So the next step is, Shirley, is to open it up. Try to get it open. See if you can get it open. It's not easy to do. If you already have the Logix Pro open, then you need to go into the open file up here and open it. But if you don't have Logix Pro open because you lost it, then when you double click on it, it will open up for you.
Yeah.
Okay, now let's talk about this. What they want you to do is they want the door opening. So the door is opening.
Okay.
They want you to hit the close once and stop this one.
Close and
When
stop.
when you hit closed a second time, the door is going to start going down. Or if you want to go back up, you can still go up too. But generally, what they want you to do is when you hit the closed one time, the door stops. If you just put the close symbol back here, it's not going to work for you.
Okay.
What's going to happen is it's going to flip and go the other way, just like it just showed
Got
you.
it.
You can't do it that way. What you have to do is what we call flag a condition. What condition am I when I want to stop it and go down close? I'm moving what? Up.
When you're
I'm
moving,
opening the door and I want to hit close, and then I want to stop the door and go down. So let me explain how this is going to work for you. I want to flag that condition. The door is moving up and I'm going to hit closed, right?
okay.
The flags you're going to use are your internal B3 relays. So I'm motioning up, and I got that as my input for that B3. I hit close, and guess what? That B3 comes on, but I got to lock it on. You understand?
Mm-hmm.
So if I lock it on, I'm good. When it's locked on, that's going to stop the door from going up. It's also going to block the door, the closed, from happening until I remove that. So you can use as many of those flags as you want to, the B3s, but you don't need that many to do this. You can, if you really play your cards right, get away with one or two of them to do it.
Okay.
My suggestion to you is at least use two, because you want to flag one condition going up and a different condition coming down. Okay.
Okay.
The stop still works as it always has, so it'll stop it in midstream. But if I'm going up and I said, man, I need to go down, I hit close once, it stops the thing from operating. When I hit close a second time, it's going to start to close. Same going down. If I'm closing and I want to go up, I hit the open, it stops it. When I hit the open the second time, I want it to go up. I have to flag the conditions of when the B3s are going to come into play. So either I'm moving up or I'm moving down, and I hit either open or close, then I lock that bit on. Something has to stop that bit from being locked on. So remember that.
Okay.
And what that is you have to figure out.
Okay.
All right. And I want you to play with this and see if you can figure it out. May take you 2 bits to flag one condition. Possibly. I want you to play with it, look around, see if you can figure it out. If you can figure it out, that's good. Try not to use any AI stuff. Try to figure this out on your own. I want you to fail on this because this is what I want my students to do is to fail. And if they go out and get something where I know where they're all at, so they can't fool me. Oh, look what I did this. I said, no, you got that off AI. I can tell exactly where you got that from. It's obvious. You didn't learn how to do this. And there you go.
All right.
Yeah, so I mean, try to figure it out. Try to do it on your own. And if you don't get it, it is okay, guys. It is okay. Because students have struggled with this. First time I saw this, I was thinking, well, what am I going to do with this? You know, and I had to figure out the using. I already you knew to use the B3s, but I
Yeah.
didn't understand how I was going to use the B3s until I got into a program trial and error.
Yep.
That's what's going to get it to you. This is the key trick to this program. Do they know how to use a B3 to flag a condition and make something happen? That is the key programming trick on this one. If they learn that, they've got it down. When we come back in November, beginning of November sometime, we'll plan a day that's going to work, not Thanksgiving, but plan a day that's going to work. We're going to get together and have you guys do the silo project too. That's
Okay.
the 2 big ones for that one. Okay. And what's going to happen with that is you guys are going to be able to go in there and we're going to talk about process flow. And now we're going into mode range. What mode are you in? What are you looking at? We're actually going to start that with the silo project next, okay? That I'll do with you in November. We'll look at this and then I'll probably give you what you need to do to make this one work because we don't have a lot of time. I hate going over an hour, but you know, this takes a little time to do.
This is
And
great.
then we'll show you how to go fix this one and then you guys can fix yours at your own leisure. And then we'll start on the other one. Use this thing. This thing is great for programming the 500 and there's still tons of 500 out there. And so you need to show them this so they know how to program 500 while you're doing 5,000 on the other side. And so the next range, I'm going to be bringing you in the next training session. We're going to be doing advanced 500. And I'm going to attempt to try and get you guys enough in there. I might have to pair you up because I don't have a lot of 5,000. They're expensive. But I have enough. I think I can make you guys work together on some projects with the 5,000. All right.
Cool.
All right. I will see you guys next time.